Hi, today we would like to introduce you to uniform distribution, which are discrete uniform distribution and continuous uniform distribution. First, we would like to look at history of uniform distribution. According to the first source that we found, it is said that the first uses of what we call uniform distribution occur very early. Discrete arguably already in Cardano and continuous in Simpson and Bayes. Next, another source said that the uniform distribution comes from the theory of equidistribution. It is about 100 years old and has been developed primarily by the number of theorists and theoretical computer scientists. Hermann Weyl in 1916 said that various new examples of completely uniform distributed sequence in the metric sense can be easily exhibited. In particular, we point out natural generalization of the original p multiplied equidistributed sequence kpt mod 1 k more than equal 1 where p epsilon n and t epsilon 0 1. The study of which was initiated by Weyl in the aforementioned manuscript, followed up by Davenport, Erdős, and Leveque in 1963, and greatly extended by Russell Lyons in 1988. In this context, an application to infinitely distributed Kotzman number Tk mod 1 k more than equal to 1 where t epsilon 1 to a for some a more than 1.
Next, we will talk about the real-life problem, example, and formulas. When dealing with discrete outcomes, the uniform probability for any specific outcome is defined, where 1 is divided by n. Here's the example of discrete uniform distribution, which is the dice roll probability. When we roll the dice, we have 6 outcomes, the number 1, 2, 3, 4, 5, or 6. So, we know the dice roll have a fixed number of outcomes. Also, assuming the dice roll is fair, the probability of each outcome is the same. So, the probability of any number being rolled is 6. There are 6 numbers on the dice. Therefore, the probability of each outcome on the dice roll is 1 over 6.
When dealing with continuous outcomes, the probability for any specific outcome is undefined. It can only find probability over a range of outcomes. Here's the example for the continuous uniform distribution. On average, 30 minutes TV shows have 20 minutes of actual program. Let's assume the probability is uniformly distributed from a low of 15 minutes to a high 23 minutes. For continuous uniform distribution, the formula for probability density function is equal to 1 divided by b minus a, whereas the mean is a plus b divided by 2 and the variance is b minus a to the power of 2 divided by 12. From the example, we can set up from the formula stated above that a is equal to 15 and b is equal to 23. Just insert the value into the formula and well, you can get the probability density function of 0.125. As for the mean, we get the value of 19 and the variance is 5.33.